Hey everyone, welcome back to the channel. Today we are tearing down the most fundamental block of computer science, that is the array. If you have ever wondered how computers organize data efficiently, or if you are preparing for coding interviews, you have to master this first. Think of an array like a pillbox. You know those daily organizers? It has fixed compartments. You can't magically stretch it to add a day 8 to a 7-day week. It has a fixed dimension. It holds the same type of things. Pills in every slot, not pills in one and coins in another. This represents homogeneous data like all integers. And finally, the compartments are right next to each other with no gaps. That is contiguous memory. Why do we even need arrays? Imagine you have to store 1 million integers. Without an array, you would have to declare variable like int a, int b, int value 1, int value 2, likewise. It would be an absolute nightmare. The code becomes unreadable and impossible to maintain. The solution is the array. Instead of a million names, we use one single variable name and access everything using an index. We go from chaos to order instantly. Let's look under the hood. In your RAM, an array is a contiguous block. The compiler looks for a strict sequence of free cells. There is absolutely no scattering allowed. This physical strictness is what makes arrays fast. But what about 2D arrays like a Sudoku grid? Here is the secret. 2D arrays are an illusion. Your RAM is always 1D. When you create a grid, the computer actually flattens it out using something called row measure order. It takes row 0, then places row 1 right after it, and so on. It is a single long line masquerading as a grid. To master arrays, you need to understand the 6 standard operations. Let's break them down with their time and space complexity. First is creation. Creating an array is fast. The declaration is big O1. However, fully initializing it takes big O(n) because you have to visit every slot to put data in. Second is insertion. Insertion is tricky. Since the size is fixed, you can only insert if there is an empty space. If the index is valid, boom, you drop it in. This is big O1 time complexity. Why? Because you don't have to shift anything. You just write to a specific address. Third is traversal. Traversal just means visiting every single element. We use a simple for loop. Since we visit n elements, the time complexity is big O(n). Space is big O1 because we are not creating new data structure, just looking. Fourth is access. This is the array superpower. Access. If I want the fifth element, I don't count 1, 2, 3, 4, 5. The computer uses math, base address plus offset. It jumps directly to the memory address. That is why access is big O1. It is instant, regardless of array size. Fifth is search. Search is different from access. In access, you have the index. In search, you have the value, and you are looking for the index. In the worst case, your item is at the very end. You have to check every single box. That makes linear search big O(n). Last is deletion. Remember, arrays cannot shrink. You can't actually delete a slot. You just reset the value to a placeholder like integer dot mean value because we just overwrite one spot. The time complexity is big O1. Where do we actually use this? First, dynamic programming. Look at the longest palindromic substring problem. A naive solution is big O(n) to the power 3, which is too slow. By using a 2D array to store our intermediate results, we drop that down to big O(n) square. The array acts as a cache for our logic. Second, hashing. Hash tables, the most popular data structure, rely entirely on the array's big O1 access speed. The hash function calculates an index and the array gives us the storage slot instantly. So when you should use an array, use it when you have homogeneous data, that is same types, and you know the quantity of data beforehand. Speed is your priority here. Avoid it if you have mixed data types or if you don't know how much data you will have. If you need frequent resizing, arrays are painful because you have to copy everything to a new bigger array. Before you go, here is your cheat sheet to memorize everything we just covered. First, the definition. An array is a collection of items of the same type stored at contiguous memory location. Second, the memory rule. 1D arrays are physical blocks. 2D arrays are just an illusion flattened by row measure order. Third, the complexity cheat sheet. We see fast operation big O1 is the operation access, insertion, deletion, and slow operation big ON is search and traversal. Fourth is the golden rule. Use arrays for speed when size is known. Avoid them when size is unknown. That brings us to the limit of arrays. They are rigid. If your array is full, it is full. If you need something flexible that grows with your data, you need a linked list. And that is exactly what we will cover in the next video. If you found this helpful, hit that subscribe button for more tech tutorials. This is Kumar signing off.